Hello students, in this video we are going to study about the conformations in alkanes. Let us take an example of alkane, that is ethane. We are familiar with the structure for ethane, that it have two carbon and bonded with the hydrogen. So total 6 hydrogens are there and 2 carbon in the ethane molecule. When we look at the three-dimensional structure of ethane, from this, these two are the carbon and these are the 6 hydrogen. So it have a tetrahedral geometry because of sp3 hybridized carbon. Now here, these alkanes containing carbon-carbon single bond, that is actually sigma bond. And the electron distribution of the sigma molecular orbital is symmetrical around the internuclear axis of CC bond, which is not disturbed due to the rotation about its axis. Because of this reason, this permits the free rotation of CC single bond. Because of this only, the CC single bond can be freely rotated. That means free rotation of a CC single bond is possible. And this rotation results in different spatial arrangement of atom in the space, which can change one into one another. So let us make the three-dimensional structure of ethane by using the ball and stick in this way that is shown here. And when you have the model with you, when you keep one of the carbon as stationary, and when you rotate this carbon, that is one of the carbon you have to keep, that is one of the ball you have to keep stationary, and you have to rotate the other carbon. So considering the ball and stick model of ethane, keep one of the carbon atom stationary. I am keeping this carbon atom as stationary and rotate the other carbon atom around the CC axis, and this rotation results into infinite number of spatial arrangement of hydrogen atom attached to one carbon atom with respect to the hydrogen atom attached to the other carbon atoms. That means if I am rotating this one, I am keeping this one as stationary, and if I rotate this one, so definitely what happened, now this hydrogen what we have here, it gets shifted, and now it is shifted in this way, so that it gives a one spatial arrangement. Again when it is rotated like this, so we can get an infinite number of spatial arrangement will be getting. That is actually are called as isomers. So these different arrangement of atoms in a molecule which can be obtained due to the rotation about the CC single bond are called as conformations. These are also called as conformational isomers, and in short we can use these isomers as conformers. So there are infinite number of conformations of ethane which is possible when we rotate one of the carbon atom about CC single bond. So these are called as conformations, and the isomers are called as conformers or the conformational isomers. So there are infinite number of conformations of ethane, but there are two extreme cases. Let us discuss that extreme cases. That is, first one is eclipsed conformation. When we view the molecule of ethane at CC bond head on, we can see the structure will be in this way. So here the ethane molecule which have two number of carbon atom. So here the first carbon atom we represent with this dot, and the second carbon atom, that is the back carbon atom, will represent by a circle. As we know that on each carbon there is 3 hydrogen. So the 3 hydrogen here that is this hydrogen, this and this hydrogen is the hydrogen which is on the attached to the front carbon, and the other three hydrogen, that is these three hydrogen, are the hydrogen which is attached to the back carbon. So we can represent the molecule in this way, that is it is a structure which is drawn here, that is the molecule of ethane, which is viewed at the CC bond head on. When we view in this way, we can make the structure in this way. But when we view the molecule along the molecular axis, that is, it is then projected on the paper by drawing the central CC bond as a somewhat like this. So we get when the structure in this way when we are viewing the molecule along the molecular axis. Along the molecular axis means like this is the 3 hydrogen on each carbon. So when we view along the molecular axis in this way, so we make the structure in this way. So here also this is both are the structure for ethane, but this is actually the structure which is drawn, that is drawn when we view the molecule at the CC bond head on, and this is the ethane molecule which is drawn here, that is the molecule when it is viewed along the molecular axis. So it will be more clear when you have the model in front of you. You can have the two different views, and on the basis of the views we can make the two structures in this way. So here in the second structure, this is the front carbon and this one is the back carbon. So front carbon is attached with the 3 hydrogen which is shown here, and the back hydrogen is attached with the 3 hydrogen. Now when we rotate one of the carbon, so at the time we can see that the number of conformations of ethanes are possible, but here the 2 extreme cases are there. Which are the 2 extreme cases? That is, in one of the conformation in which the hydrogen atom attached to 2 carbon atoms are close together as possible, that is called as Eclipsed Conformation. That you can see in this, while rotating, a case will come where the 2 hydrogen, that is the front hydrogen and the back hydrogen, that is the hydrogen of front carbon and back carbon hydrogen, when they are so close to each other, that you can see when they are close together as possible, that conformation is called as eclipsed. Here also you can see when we view this along the molecular axis, we can view that this is the front carbon hydrogen and this is the back carbon hydrogen. Now these have the closest as possible here. So this is actually called as eclipsed conformation. What we call this one? Eclipsed conformation. And again, while rotating this one, what happened when you compare here? This is the front hydrogen, this is the back hydrogen. Now you can see there is these are far from each other, and that is a possibility that also you can see in this picture also. So here this conformation is called as staggered, that is in which the hydrogen are as far as apart as possible is known as staggered conformation. So when you compare both the picture here, that is the staggered and eclipsed form, in this you can see that here the front carbon hydrogen, this is the front carbon hydrogen, and here is the front carbon hydrogen. And which one is the back here? This is the back carbon hydrogen, this is the back carbon hydrogen. Now when you look at here in the first case, that is in this case, the front carbon hydrogen and back carbon hydrogen are close together as possible. But in this case, they are far as possible. So that is what we can call it as 2 extreme cases, that is eclipsed and staggered conformation. That is also be seen in this case. This is also eclipsed form, this one is staggered form. So here you can see the first carbon is stationary, the second carbon was rotated. At the time you can see this hydrogen, that is this hydrogen now its position is on this side. So here we have studied the two conformations, eclipsed and staggered, and intermediate conformations were actually skew conformation, named as skew conformation. And we have viewed the molecule in two ways, that is the molecule are viewed at the CC bond head, and the molecules can be viewed along the molecular axis. So this way of projection is called as Newman's projection, and the view of molecule, that is along the molecular axis, this type of projection is called as Sawhorse projections. So this is the conformations of alkanes. This one is the three-dimensional view of ethane having two carbon atom bonded by single bond and each having 3 hydrogen. From this animation, we can able to clearly view the two projections, that is Sawhorse projection and Newman projection. When the molecule is viewed at CC bond on head, then this type of projection is called as Newman projections. In this animation, we can able to view the molecular axis. This molecule can be viewed as along the molecular axis, that is called as Sawhorse projections. In the staggered form of ethane, the electron clouds of carbon and hydrogen, because they are as far as possible, so there are minimum repulsive forces. Here there are minimum repulsive forces, therefore minimum energy and maximum stability. There is maximum stability because these are far as possible. Therefore, there is a minimum repulsive forces between them. So, therefore, there is a maximum stability of the molecule. So, on the other hand, when the staggered form changes into the eclipsed form, then what happened? The electron clouds of carbon hydrogen atom are closer to each other. So, when they are closer to each other, that is in the eclipsed form, so what happened here? The repulsion increases, that is repulsive forces increases. Therefore, it have a minimum stability. It have minimum stability. So, what we can conclude from this one? Because there is a maximum repulsion in the case of eclipsed form, therefore it is minimum stability it have, and the staggered form, because there is a maximum stability because the electron clouds are as far as possible, therefore minimum repulsion is there. So what we can conclude that the staggered was more stable and the eclipse was minimum stability. It has minimum stability. So to check the increased repulsive forces, molecules will have to possess more energy and thus has lesser stability. As already mentioned, the repulsive interactions between the electron clouds, so which affect the stability of the conformation. Therefore, it is called as torsional strain. It is called as torsional strain. And this is the magnitude of the strain. This depend upon the angle of rotation about CC bond. This angle is called as that is dihedral angle. This is called as dihedral angle or torsional angle. From this, we can conclude that the magnitude of the strain depends upon the angle of rotation about the CC bond. This angle is called as dihedral angle, and from all the conformations of ethane, the staggered form, that is this form. Staggered form has the least torsional strain and the eclipsed form have the maximum torsional strain. Therefore, the stability depends upon the strain. So, this is we have learnt about the conformations of alkane, that is the two cases, the two extreme cases, eclipsed and staggered, and the intermediate are called as Q conformation. So, we have learned the two way of representing the structure for ethane, that is the two different views, that is representing by Newman projection view and the other one is Sawhorse projection view. So this is all about this video. Have a nice day.